Hello, everybody, and welcome back to another visual pattern challenge. Here's our pattern today. We have step 1, step 2, step 3. Your challenge would be to predict how many of these shaded squares we're going to have in step number 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of boxes in any step at all? If you'd like to accept that challenge, pause the video, work it out. Okay. Let's just look and see if we can determine visually what's happening with this pattern. I guess in the first one, I just see these two boxes shaded in here. They are in a sort of a diagonal pattern to each other. And in step 2, it looks like the boxes are bigger, the squares are bigger, they've grown in size. So these were 1 by 1. Now I've got 2 by 2 boxes, but they have this overlap area here. And in this one, yeah, they're 3 by 3, but the overlap area has also grown. So it looks like the box size is going up by 1 each turn, and the overlap size is going up by 1 each turn. So here it was 1 by 1. Here it was 2 by 2, the overlap, I mean. So here I think we'll have boxes that are 4 by 4, right? But the overlap will be bigger as well. So these are 4 by 4, and the overlap should be 3 by 3. So how many boxes would that be? So in this one, 4 by 4 is 16, and then the edge that remains after the overlap, there'd be 1, 2, 3, 4 here, and 1, 2, 3, 4 there. Well, but only 3 more because we don't want to double count the corner one. So that'd be 16 plus 7, so 23, I think. So that's my prediction for step 4. Now, when you see squares growing in area from step to step, it suggests that this is not a simple linear pattern. It's probably going to be quadratic. There'll be an x squared. But let's analyze the numbers and see if that's right. I'm going to make a chart here with the step number and the number of squares in each step. And we'll see if this looks like a quadratic according to the numbers. So in step 1, we have 2 squares. In step 2, that's 4, 5, 6, 7. In step 3, 9, 10, 11, 12, 13, 14. Okay. And in step 4, we're predicting 23. To analyze these numbers, we'll take the differences between the steps. So 7 minus 2 is 5, 14 minus 7 is 7, 23 minus 14, that's 9. Aha, so we're not getting a constant in our differences, which means this is definitely not a linear pattern. And that's okay, that's what our hunch was, that it wasn't linear. If we think it's quadratic, we can take the difference of the differences. So 7 minus 5 is 2, 9 minus 7 is 2. If you get a constant there, like we are, that means it is a quadratic, and we're going to have an x squared somewhere in this equation. Now, at this point, if you've been following along with these other videos, you may notice that you've seen a pattern very similar to this one before. We had squares with overlap. On those squares, they had handily color-coded things, so you could notice that pretty easily. We're going to use the same technique on this one. In each turn, you have 2 of these bigger squares, 2 of these squares, and then a smaller overlap part. To get the right count, we're going to have the 2 squares minus 1 of the overlap area. And the squares in each step are pretty easy. It's just the step number squared, right? So in step 1, they're 1 by 1 squares. In step 2, they're 2 by 2. In step 3, 3 by 3. So there's 2 of those. So I would call that 2x squared, and that would give those 2 boxes. However, because they overlap, we have to subtract the overlap once, so we're not counting it twice. And the overlap, well, it looks like it's 1 less on a side than the step number. So in step 2, we have a 1 by 1 square. In step 1, we have nothing. So it's really, you can think of that as a 0 by 0 square of overlap. So the way I'm going to write that is I'm going to make the step number, subtract 1 from it, and square that. And then this whole thing is the overlap, so I have to subtract it from our 2 squares. So this should be an equation, and you could leave it just like this. This has some advantages because it corresponds to what's visually happening up here in a way that's helpful. You could also FOIL this out and do the subtraction. If you FOIL that out, I think you'll get x squared and then plus 2x, and then minus 1, I think. Yeah, I think that's right. Y squared, or sorry, y equals x squared plus 2x minus 1. So that I'm going to write that down as my equation, but let's check it now that we have it. Does it actually work with what we have up here? So here that would be 1 squared plus 2 minus 1, and yeah, that equals 2. Here it would be 2 squared plus 2 times 2 minus 1. So that'd be 4 plus 4 minus 1, that would be 7. Yeah, and in step 3, let's just check it there. So 3 squared plus 2 times 3 minus 1. So that's 9 plus 6 minus 9 plus 6. Yeah, that is 14. Very good. Okay, so this equation, I think we can be confident in that. And then to figure out step 43, we just have to plug 43 into that equation. So y equals 43 squared plus 2 times 43 minus 1. So 43 squared is 1849, and then we're going to add 86 to that, which gives you 1935, and we're going to subtract 1. So 1934 is what I'm getting. Did you get that? Did you get 23 for step number 4? Let me know. Thanks, everybody.